is just the starter code. So you know how to use the generator, the handout that I gave you online. So we'll give you the starter code, and if you run the starter code, I think my server is already running. So now if I just run, okay, this is what you will see. Just the spinning cube, right? Nothing fancy, okay? And if I look at the detail of the code here, and let me switch to presentation mode, the starter code will give you a spinning cube, and the geometry of the cube is generated here at line 44, and the material is of mass foam material. So now I'm going to create my own. So let me call it shader object or shader whatever, okay? And now, or maybe let me call it shader material. I think I want to create the property first. Yeah, I like to call it shader prop. So the two main attributes that I have to fill in here would be vertex shader attribute, and you need to fill in some text there, and then the second one is fragment shader attribute. Okay, so technically what has to go there is a string of your code. Okay, but it's too cluttered to write the code as a long string. So the common technique is to write your code inside a new HTML element. Okay, so then I'm going to add a new script here. Okay, and the type of that script is X shader X vertex. So this is the type for vertex shader. And I need to have both vertex shader and fragment shader. They come in pair always. Okay, and I need to give it some ID. Let me call it just fs0, and let me call this one script. I misspelled script, and I need to give a name to the second element here. Let me call it fs0. Okay, so this is when you will write your code. So how is the connection made? And then in your shader property, you will get the content of that element. And the way to do it is by calling document get element by ID, get element by ID, and the string ID I'm using for my tags are vs0, and same thing for my fragment shader, get element by ID. Is it misspelled? Get element
No, I don't know why it's not.
by ID fs0. Okay, looks correct to me. Okay. So how do I write a shader? Well, for the first one, well, a shader is just looks like a C program. Okay, so I'm going to put void main, and same thing for my vertex fragment shader. So it looks like a C program, and I can put some code in here. So what do I need to generate? In my vertex shader, I need to tell the vertex shader what will be the output. What will be the output, right? So this output will be a varying variable that will be used by the rasterizer. Okay? So let's say I want to assign a single color. What I need to do is to put a color, and I'm going to declare a variant. Okay? So my color is a vec4 or vec3. So I can use a vec4 or vec3. Okay. Now let's just place one color. Let's say I want to render my point just red. Okay. Now, I didn't go through the details here, but the outgoing output from your fragment shader has to be a fragment. And one of the important value that you have to set will be the color. What is the color I want to show up on my screen, right? And we do have a special variable for that output, and that output is known GL frag color. Okay, so question about the simple example here. So I mentioned before, the name of the variant from your Vertex processor has to match the name of the variant variable for your Fragment processor. So this is when I made the connection. So the code, let me put a comment here. So the code at the top is my Vertex shader, and the code at the bottom is my Fragment shader. Okay, and I'm going to use my COL as the output of my Vertex shader, and that output has to match with an input in my Fragment shader. And then I'm going to place that color in my Fragment output. Okay, question? So I have the code for my Vertex shader and Fragment shader, and now I need to make the connection to my object. So if I want to render my box using the new Fragment shader, then I need to replace the material property with my own. So now I can create a new material, I call it shader material, and new 3 shader material, and I want to supply the shader property shader prop object. Okay, let's run it. We may get some error here. Let's try. And now I'm going to replace that with shader mat. Okay, save, and let's see if it compiles. And let me open my debugger so we can trace any error. Oops, wrong. I want to open developer tools. There we go. Where'd it go? Oh, it's there. Okay. Okay, so let's run it. Compile, reload. Looks like we have an error. So what is the error here? The error is a long line of output. Okay. Shader could not compile. Syntax error. We do have misspelling on where?
On the code with the Vertex shader.
Validate status.
Under the shader properties.
Shader property.
The Vertex shader. That's spelled.
Vertex. Vertex. Looks like I'm dyslexic. Okay, let's try that. Oh, I think I'm missing something. We do want to get this. Remember, I mentioned that this has to be a string, right? Whatever goes in here has to be a string. What I'm going to get from my get element ID is just a tag. I don't want to put the tag. I want to put the string. So I need to say get content. Okay. Get content. Text content. Get content. Text content. Thank you. There we go. Text content. Okay, thank you. Okay, let's try. Save and run. Reload. Still we have an error. What is the error now? Maybe some misspelling. Constructor, too many arguments. This is for matching. Oh, mismatch between vec3 and vec4. Okay, and this is inside line 76. So the error tells me the error is on line 76. Oh, probably I 76. Oh, okay. I have to use vec4, not vec3, of course, because I declare it as a vec4, but when I initialize, I'm using vec3. Of course, that's a mistake. Okay, there we go. Run one more time. Run. Nothing shows up here. What's wrong? It doesn't give you any output, any debugging error. See, apparently too many errors. Too many errors. Varying vector for.
Is it the correct way to comment inside the script? It's less than tag. Can you use
Oh yeah, it is a C code. Yeah. What is missing now? Oh yeah. Okay. I forgot. I need to transform the vertex. Okay, because what's happening here is everything is done inside your view volume. I forgot to do that part, the important part. Right? I need to tell the GPU that point, the incoming point. You specify the coordinates with respect to the world coordinate. But when you render it, you have to transform that coordinate into the camera coordinate frame, So I need to do that transformation. I'm missing that part. So I need to do multiplication here. So in addition to setting the color, I also have to multiply my position with the model view matrix and the projection matrix. Okay, I'm missing that part. So I need to do some calculation, and that will go to another special variable called the GL position. Okay, and I need to multiply the incoming position, the incoming vertex with my projection matrix, and multiply model view matrix, and I need to multiply with the XYZ position of my object. Okay, so the output, one of the important output from your vertex shader is the position, and the important output from the fragment processor is the fragment color. So let's run it this time. Run. Nope. What is missing now? Can compile multiplication, wrong operation, of course, because projection matrix is a 4x4, okay, and model view matrix is a 4x4. My position is vec3, so I need to convert my position into vec4. So vec4 position, comma 1. Okay, so by adding the fourth component, and we're converting from Cartesian coordinate to homogeneous coordinate. Last try, and hopefully this time you'll show up. Yes. Okay. So it's not too interesting, but it works. Okay. So question about this first example. Okay. Now let's change the code a little bit. I can put some logic. Let's say I want to assign two different colors to my cube. Okay. Let's do something like, if the x is positive, I want to render blue, and if x is negative, I want to render green, something like that. So how do I do that? Well, I cannot change my logic. I can change my input, my vertex code. Instead of using just one color, now I can put an if statement. Okay, depending on the incoming vertex, if the position, the x value of my vertex is negative, let's say, I want to put one color, otherwise I want to put a different color, and I can just put an else here, and then I can copy that to a different color. Let's say I'm going to change to something else, okay, just like that. And let's see the output now. Run again, run, Error. What did I do wrong? Less than. Okay. Oh, okay. Okay. The type checking is tricky here. What I'm trying to do here is I'm trying to compare a floating point value with an integer, so it doesn't work. So I need to type that as 0.0. Okay. So run again. Yep. Okay. So now you can see something different. Okay. So start adding more logic here. Let's say I want to do something different. Let's say if I want to multiply the x and y, if the multiplication of x and y position is negative, I want to render one color. Otherwise, I'm going to render a different color. Let's see the effect of this new logic. Okay, so you can start to play more. Okay, and then let me introduce to a uniform. Okay, now in my example, I hard code the two colors into my shader. What if you want to have the user control the color? That means the color has to come from outside. Okay? The color has to come from outside, and the way to do it is by using the uniform shared memory. Okay? So now if I'm going to add my variable, I'm going to allow the user to change the color from outside by using a uniform. And in order to do that, and then I will just need to declare a uniform variable. Okay? And for my color, let's say I'm going to use a vec 4 again. Okay? Let me call it color dark or whatever. Okay? I just pick up some name here. So this will be my input. And then let's say I'm going to use that to render the first condition, color dark. Okay, now of course when you introduce uniform, you need to make the connection between your code, your GPU code, and your CPU code. And the way to change that is now I need to declare a uniform in my shader property. So in addition to the two attributes of Vertex shader and Fragment shader, I do have to add another property. This block is known as uniforms because I can put as many uniforms as I like. Okay? How do I put my uniform variables? This is just a type value pair. And the name that I'm going to declare here has to match the name that I'm using in my code. I'm using color dark. So then the property that I have to add here will be color underscore dark, exact spelling, don't change anything. Okay? And whatever I type inside will be type value. So the type is a vector 4. Is it vector 4? Yes. Okay, the type is vector 4 here. So when I encode my type, it is v4 is not vector 4, and the value will be whatever value for your color. Okay, I can generate a new color. Let's say new 3 vector 4, and now you can put a color here. 0.3, 0.2, 0.6, and 1.0. Okay, so now you can make the connection between your uniform variables and your Vertex code. Am I missing something here? New, I don't need a semicolon at the end. Type value, comma, I think that looks correct to me. Okay, color dark, and the variable name in my uniform is color dark. Okay, let's try compile. So the color will change depending on your setting of your uniform. Yep. Okay, question so far? Okay, now I'm going to show you one more example. I think we do have time. Now, what I'm doing now, I'm trying to color. What I'm trying to do now is I'm trying to alternate the color in my vertex shader, right? Well, can I recolor my points in my fragment shader? Yes, right? Because we know that the ultimate output here is the fragment color. One of the ultimate output is fragment color, right? So what I can, if I want to change my input, my logic, what I can do is I can delay the actual color into my Fragment processor. But I think I'm not going to have enough time, so let me just stop here. So I will continue next week.